Alright, here we go. Let's implement this class. So, just to make sure everybody understands, what we're about to implement is both the CNN and the VAE in the same class. And that's why the name we're going to give to that class is going to be convolutional VAE, or we're going to call it conv VAE for more simplicity. Alright, let's build that conv VAE class. Here we go, back in Python. So to create a class in Python, we start with class, then we give a name to that class, and as we just said, we are going to call that conv VAE for our CNN VAE, the part of our AI that will see the input images in reality and will reconstruct them in a dream. And this is exactly what we will build, what we will make happen in this class. So conv VAE class, and then it's going to take as input just the object variable, and that's because we're not inheriting from any class. All right, and then of course colon, and here we go for the first method, which as always is the init method, which will initialize all the parameters and the variables of the future conv VAE instances of this class. All right, so let's actually say that in a comment so that we can structure this code the best way and so that you can visualize clearly what we're doing. So let's say indeed that what we're about to do now is about initializing all the parameters and the variables of the conv VAE class. And here we go with the first method, which is the init method, spelled like this, as always, between two double underscores. And now, get ready. This init method is going to take a lot of arguments, so let's list them one by one. No worries, they will be very simple to understand. So the first one is, as always, self, which will correspond to the object. Then the second one is going to be z_size, which, as you might guess, is going to be the size of the latent vector, which is, remember, at the center of the variational autoencoder, which will be composed of 1024 elements, and from which the variational autoencoder will reconstruct the input images. So let's go back to Python. And right now in the arguments we can specify a default value, but it doesn't really matter what we input here, because at some point we will input 1024, because we're implementing the exact same architecture as in the article with the 1024 elements here. So let's just give any default value, and we're going to give 32. Then the next argument is going to be the batch size, which is going to be the size of the different batches of input and target, because of course we're doing batch learning, meaning that we're learning on batches and inputs and targets as opposed to single input and target. So again, we can specify a default value here, and well, we can just give the default value of 1 so far, but of course at some point we will give another value when we start batch learning, or training on batches. Then third argument is going to be the inevitable, the one that is always here, which is the learning rate. And same as a default value, we'll just give 0.0001. We will give the real value of the learning rate later. Then the next argument is going to be the KL tolerance, which is a parameter we'll use to compute the KL loss, because I remind that the loss we'll use to train the VAE will be the sum of two losses. The first one is the classic mean squared error loss, and the second one is the KL loss, which stands for Kullback-Leibler loss. And this KL tolerance will be, of course, a parameter of this KL loss. And as a default value, we'll give 0.5. Then 3 more arguments to go. The next one is training, which is the mode, either equal to false if we are in inference mode, and true if of course we are in training mode. And so by default we will set it equal to false, because naturally by default we want to do inference. But as soon as we want to train the VAE, we'll set that of course equal to true. Then the next argument is going to be reuse, and that's for the variable scope of TensorFlow, because with TensorFlow we work with variable scopes, which is basically a container of variables, and the reuse variable here says whether or not you're going to reuse the variable scope, and this is again a boolean equal to false or true. False means of course that you're not going to reuse the variable scope, and true means that you're going to reuse it. And for our VAE, and here, well, by default, we're just going to set it equal to false. All right, and then final argument here of this init method, which is the GPU mode, which is again a boolean equal to false or true. False means that we're not going to use a GPU for the training, and true means that indeed we're going to use one. And by default, we're going to set that equal as well to false. All right, and that's it for the arguments of this init method. So now let's introduce and initialize, as we said, the parameters and variables of the conv-VAE class. And so now very simply, we're going to create some object variables for each of the arguments we have here. Indeed, these are only arguments, but we want to create some object variables as well, which will be exactly the same arguments here, and to which we're going to initialize as the values given in the arguments here when we create the conv-VAE class. So let's do this. Let's just take them one by one, and let's add a cell first, because indeed by putting a cell first we specify that these variables are variables of the objects, specific to the object, which are the future instances of the conv-VAE class that we'll create later. So the size of the latent vector will be equal to, of course, the value of the argument given when we create the object. So make sure to understand the difference here. This is the variable of the object, and this is the value of the argument provided here. Then let's move on to the next one, batch size. So we're going to do exactly the same now. Self dot batch size equals batch size, the argument given here. Then again, same thing, learning rate. Here we go. That's for the third object variable. Self dot learning rate equals learning rate, the argument provided here. Then same of course for the KL tolerance, the parameter we'll use for our KL loss. So here we go, self dot KL tolerance, the object variable which we initialize to KL tolerance, the argument here. And then same is training, the training mode, whether we are in training mode or inference mode. So here we go again, self dot is training, the variable object, which will be initialized to is training, the argument here. And then lastly, because we actually won't need a variable object for this one, but we do need a variable object for the reuse variable. So here we go again, self dot reuse, the variable object, will be initialized to reuse the argument. And now that's where we can create the TensorFlow variable scope. And to create one, we need to start with width. Then, since this is an advanced structure by TensorFlow, we need to call TensorFlow, which has the shortcut TF. And then from TensorFlow, we're going to get the variable scope function, which will exactly create the variable scope. And now, in some parentheses, we need to, as you can see, specify the name of that scope, and it has to be entered in quotes. And the name we're going to give to that variable scope is going to be, the scope of all the variables attached to the convolutional VAE model. So we're just going to call this, conv VAE. And then that's where the reuse argument and also object variable will come into play, because as you can see, reuse is actually an argument of the TensorFlow variable scope. And so now be careful, there will be three things to distinguish. The reuse argument here, which is the argument of the TensorFlow variable scope function, which we will initialize to the reuse variable of the object. So I'm going to take here self.reuse, which I'm going to copy and paste here. And the self.reuse is equal to the reuse argument provided here when we create the object, right? So I hope I said enough for you to not get lost in all this, But here we go, the variable scope is ready. So we don't forget to add the colon here as I just did. And then now inside the TensorFlow variable scope, this is when our last argument will come into play, the GPU mode, because indeed whether you have or not a GPU, you will have the option to use it. So let's offer that option right away. The way we're going to do this is with an if not GPU mode, meaning if GPU mode is not equal to true, meaning basically if we're going to use our CPU. If not GPU mode, then what are we going to do now? Well, if we're going to use our CPU, we're going to specify this, but we need to tell that to TensorFlow. We need to specify to TensorFlow that indeed we're going to use our CPU. And the way you can do that with TensorFlow is with a with again, and then TF, I'm calling the TensorFlow library again, from which I'm going to get this time the device function, inside which I'm going to enter in quotes /CPU:0, right? This is a code to specify that we're going to use our CPU if we don't have a GPU like CUDA for the training or even the inference, except that for the inference, you definitely don't need a GPU. All right, then let's not forget the colon, and inside we can provide some logging info just to give some extra information saying that indeed our model is using the CPU. These are just some extra useful information, but not compulsory, of course. And then now, however, the thing that we have to do is to initiate the building of the graph, which we do by calling the build graph method, which is exactly going to be the next method we will build to build the whole architecture of the convolutional VAE model and also the training operations. All right, perfect. Then we're going to get in the other condition, whether we are in GPU mode, that is when GPU mode equals to true, and which we can get with a simple else, because this is the complementary condition. So else here, and inside, well, in that condition we'll have directly the GPU TensorFlow device, so we don't have to do another with TF device GPU, but instead we're just going to get the new logging info, which will be this time exactly the same, but replacing CPU by GPU. And then again, we will initiate the building of the graph by calling our build graph method, which we will build in the next tutorial, or in the next couple of tutorials, because this is going to be a big method. And so that's done for this complementary else condition, where we are in GPU mode. And now the last thing we need to do to finish is to introduce a last object variable of our conv_VAE class, which is self.init session with some parentheses, and which will be used to initialize the future TensorFlow session that we will run for either the inference or the training of our VAE model. That's the way we do things with TensorFlow sessions. You will see that later on in the code. So that's it for this first init method. And now get ready for the next one, because this will be the big method inside which we will build the whole architecture of the convolutional variational autoencoder model. So get some good energy for this, because we have a lot to do. So I'll see you after a little break, and until then, enjoy artificial intelligence.